In this video, we're going to look at topic 77, example 4, sketch the graph from a written description. So how can you sketch a graph of the polynomial function f from a verbal or written description, whichever one you want to look at it as. And they give us some statements here, right? They tell us that f of x is positive on an interval, they tell us it's negative on a couple other intervals, it's decreasing and it's increasing. So what I'm going to do is I'm going to draw a very rough sketch and kind of color code some stuff. This might be a little bit of extra work, but usually following this method I find makes it a lot more straightforward. So I'm going to label some points along my x-axis. So I'll say that this is 1, 2, 3, 4, 5, and 6. And this will be -1, -2, and so on. Right. I'm not actually going to label anything on the y-axis because they don't tell me anything. And you'll see as this goes through, I know it ahead of time because I've done this problem already. But I'll explain why I'm not labeling anything on the y-axis in a couple minutes. So we're told that f of x is positive on the intervals -∞ to -4. So remember, positive means it is above the x-axis. So from -∞ to -4, we're talking in terms of x values, right? The graph is going to be positive, so that tells me the graph is going to be in this region up here. And at -4, it's going to go from being positive to negative. Right? So we're going to have an intersection point at -4. It's also positive from -1 to 4. So I'm going to shade that in. So that will be here. So my graph from 1 to 4, oh, sorry, from -1 to 4. So from -1 to 4 would be here. Let's fix that. All right, so this whole graph, this whole section is going to be positive. And this won't be my answer. I'm just using this as kind of a sketch. So that tells me I'll also have an intersection point, or sorry, not an intersection point, x-intercept at -1 and at 4, because that's where my graph is going to be changing directions, or changing from positive to negative. So the graph is negative. So let's highlight that so we know what that's talking about. The graph is negative from -4 to -1, which we kind of figured, right? Because if it's not positive, it's going to have to be negative. So the graph will be down here somewhere. And from 4 to infinity, so everything down here. From 4 and then going to the right. So those are my intervals. Now the next part of this is where it is increasing and decreasing. So this is where we have to be a little bit more careful. So from -infinity to -2.67, it is decreasing. So what's going to happen is the graph is going to drop down from left to right, and it's going to decrease. So -2.67, which will be somewhere about here. Let's actually do this in red. Sorry, -infinity to -2.67. So the graph is going to go from -infinity, it's going to go down this way to about -2.67. And we want to go through that intersection point. It's also going to decrease from 2 to infinity. So somewhere here, and again, I don't know exactly where, but it's going to decrease here, going through that intersection point. So from 2 to infinity, and it's going to decrease from -infinity to -2.67. Okay, somewhere, again, here. The graph is going to be, so it's going to decrease here and here. And the graph is going to increase from -2.67 to 2. And it needs to go through -1. So it's going to increase from here to here. Again, we don't know what the y value is. So this point here, we don't really know where that is. That might be 2, it might be 100. We don't actually know. But we're not worried about that. We're only worried about the x's and the intervals in that case. So we know that this is going to have more curves. It's not going to be these kind of jagged, sharp turns like these V turns. So I'm going to take that and I'm going to fix it. I'm going to clean it all up. So -5, -6, 1, 2, 3, 4, 5, 6. Again, this method might be a little bit more involved, but I've found that this works each time. So we know that the graph is going to have these intersection points or these x-intercepts, and what's going to happen is the graph is going to go through those points. It's going to decrease, then it'll increase, and then it'll decrease. And it's going to look something like this. Okay, so this would be my sketch. We'll just leave it as our sketch. This would be the actual solution, the one on the right. This is what I would submit or hand in, something similar to that. Remember, we don't actually know what the y values are, so we do not want to label the y-axis. We're only labeling the x-axis because we know specific values for that. If you can go right to the sketch, feel free to, but I found that drawing these straight type of lines and shading in the positive and negative intervals to find the x-intercepts makes the whole process significantly easier. I'd rather spend an extra minute or two to guarantee that I'm getting this right, rather than accidentally draw a poor sketch because I haven't planned this out very well. All right. Think of it as your rough draft. Okay, that's what we're going to call that. So we'll call this our rough draft. Try the try it problem and see if that makes sense. Remember, your intervals, your positive negatives will give you the x-intercepts, and the increasing and decreasing intervals will give you when the graph is going up and when it is going down. Good luck.